All right, welcome everyone, and thank you for joining us today for Mapbox Tech Backend APIs. While we are still waiting to get started, I'd love to learn about our audience like you. Where are you located? Please share your answer to the chat box. I am Bing. I'm your host for this session, and I live in Roseville, outside of Sacramento, California. During our past sessions, I've been seeing people from all over the world, like India, Japan, London. So feel free to share where are you. Cool. I saw people from San Francisco, Central American. Alaska is always on my list. I want to visit so badly. Cool. Denver. Oh yeah, it's good. Look, vacation place. Massachusetts. Actually, I live in Massachusetts for 6 years. Yeah, I live in Boston, Austin. Yeah. Awesome. Very excited to see everyone, around the world. All right. Oh yeah, I love Boston too. Boston. I'm trying to learn about my Boston accent. All right. Before we get started, a few housekeeping items. Just want to share with you. This session is 25 minutes long. Captions are available in the multiple languages. So you can check out the Zoom bar below your screen. You can see the screenshot. You can select your setting. You will be able to submit your questions through the Q&A sessions, which are also located on the bottom of your Zoom screen. Also, each session you attend this week, the more chances you have to win Mapbox swag. I love my Mapbox swag, so thank you for being with us today. Also, if you want to discover more build sessions, you can look at on the event lobby or mapbox.com/build. All right. I am Bing. I'm a product marketing manager on search team at Mapbox. I'm so passionate about connecting our product, location data with developers and the customer to solve real life challenges. And I'm very excited to be here today to explore our possibility of our API offering with you. So let's take a moment to introduce our speaker for today. We're excited to have Greg, Robert, and Ryan. They're going to walk us through the main APIs. Greg, let's start from you.
Yeah, thanks, Bing. My name is Greg Banneker. I am Senior Product Marketing Manager for our Maps service unit. So really, if it has to do with rendering, customizing, taking custom data, bringing it to your map, I'm the product marketer in that realm.
Hi everyone, I'm Robert Florence. I'm a product manager here at Mapbox. I'm focusing on geocoding and address autofill. I have a background in developing data products in the fintech and geospatial industries, and I've been with Mapbox for the past 2 years. Excited to share some insights on how our products are going to enhance your applications and improve your user experience today.
And I'm Ryan Leidig. I'm head of product for our on-demand logistics service line, include isochrones, matrix, and optimization. Our on-demand logistics vertical encompasses all of our customers who, from order ingestion to order fulfillment, is less than 18 hours. But I do touch on all kinds of logistics and OA type of items.
Awesome, thank you. Awesome. In this session, we will explore Mapbox key APIs that are going to help developer create a starting, highly customizable, and accurate mapping experience. So we will start with our Maps API with Greg. Then we will dive into our search APIs with Robert. And the last, we will explore the navigation API with Ryan. So after we discover each APIs, we will open the floor for Q&A. So feel free to drop your question to the Q&A chat. Thanks for joining us. Let's get started. Greg, I'm going to pass to you.
Okay, thank you, Bing. So I want to talk about two Maps APIs that maybe don't get as much love as some of our other APIs. Maybe a little more back-end. One's back-end, one's more front-end, but two that we want to sort of highlight today for you. So the first being the Mapbox Tile Query API, which allows you to retrieve data about specific features from raster array and vector tile sets based on a given latitude and longitude. So for vector tile sets, the Tile Query API makes it possible to query for features within a radius, to do point and polygon queries, or query for features in multiple composite layers. and also augment data from the Mapbox geocoding API with your own custom data. For raster array tile sets, it's possible to query a specific point value across different layers and bands within the tile set. That's what you're seeing here. The API is actually querying total precipitation from a rainfall data set and graphing the results. So you wouldn't visualize this. This is like a non-visualization use case here where you can actually graph the results on a map, and this could be helpful for like internal analysis. Next slide, Bing. And what I provided here is actually the code that we use to pull, using the tile query API to pull that data and turn it into that graph that you saw. So you don't need to read through this all right now, but when you like revisit the session later, you can actually see what we had here. So what can you actually visualize though? So a good example would be querying the temperature for various locations. So you could use the tile query API to enable a front-end user to query the temperature by clicking on the map. So when they click, they can see the exact temperature in a given location. This would allow users to get more precise information that they need for planning purposes versus maybe just estimating the temperature based on the color gradient you see, or like putting a graphic on top that says 27 degrees Celsius over a general area. We often also have customers that want to like maybe query the heights of buildings or terrain elevation on a front end use case. So that could be some other uses there. Okay, I also want to talk about static images. So the Mapbox Static Images API serves standalone map images generated from Mapbox Studio styles. So these images can be displayed on web and mobile devices without the aid of a mapping library or an API. They look like an embedded map, but they don't have any interactivity or controls. So how do Mapbox customers use them? They may put map images into emails or like on a digital story. They might print static images. They might use them actually to improve the perceived performance of a web page. So they'll load a static image, which is lightweight. And so the web page, maybe a home page, loads quickly, and then link that image to the actual interactive map on a different page. What you can see here in the example is actually from the Houston Association of Realtors. So they have a neighborhood section of their site where you can get more information about different sections of the city. So they've chosen to load a static image, which you can see initially with a boundary of the neighborhood versus an interactive map of that neighborhood. But then you can click on that static image and it brings you to the interactive map with all the listings. Another good example here is Shopify. So Shopify uses static images, static maps to visualize multiple deliveries on a single screen. So it helps simplify the experience of tracking all your orders by keeping all these delivery maps and status of your order within one view. But they're not necessarily sacrificing app performance by having all of these maps be interactive maps that are loading on this single view. So you can retrieve, again, a little code here, so don't worry about getting the specifics, but you could come back to this. You can retrieve a static map from a style with the URL that you see on the top there in the gray box. And then I just dropped an example there of that sort of URL in action. And on the next slide, we do actually have a static maps playground on our documentation site. So you can sort of see at the very top, it's small, but the URL updates as the parameters of the static map or the static image change. And you can play around with this on our documentation site. On the final slide for me, I did sort of zoom in a little bit on that URL just so you can see as the static image changes, the URL itself sort of adjusts to what the parameters are. And with that, I'll pass it on.
Thanks, Greg. Hey everyone, Robert again, PM for Geocoding and Address Autofill. I'm going to talk about some of the new and upcoming capabilities of our search APIs. So starting with geocoding here, I think probably everyone knows that geocoding is all about taking addresses, converting them to lat longs converting them to addresses. But we actually had a big new release this year with geocoding v6 and added some important new features. At the top of the list here is we now support unit level geocoding. So instead of just getting back the location for 123 Main Street or being able to register a user as living at 123 Main Street, you can now know the location of 123 Main Street, apartment A or apartment B, register that way, get a delivery sent right to the exact location. Also for bulk geocoders, when you have a big database of addresses or locations that you need to geocode, we have batch geocoding and structured input really improved this year. You can basically split up your address into its component parts to get way better accuracy in your results, and then you can send 1,000 queries in the same request, which simplifies, speeds up development quite significantly for our customers. We also have great coverage in Japan today. And a big change as well is that permanent geocoding, which allows you to cache results indefinitely. So if, for example, if you need to store them back in your database and refer to them later, you can now access this in a self-service manner. You don't need to contact sales or anything like that. So these are some of the V6 features that are really helping customers deliver better products through kind of verifying, standardizing, cleaning, enriching addresses and location data. Let's jump to the next one. And so just to get into some of the use cases here, geocoding has a really wide variety of use cases. First of all, unit level geocoding, which you just mentioned, powers on-demand delivery services, gets delivery drivers right to the correct door. With checkout forms, this is where our address autofill SDK comes in that wraps our geocoder. It helps you ensure that you get a valid address. It also autocomplete increases the conversion rate of end users in a shopping scenario. Address verification, this is used across some of our social media companies. They help register users in a really consistent manner. Asset and fleet tracking, they're doing reverse geocoding to kind of securely manage their fleet, keep track of them. Weather companies are also doing reverse geocoding, doing huge amounts of reverse geocoding to figure out what weather report should I really pull for this person? BI companies they'll also enable their customers that might have a huge amount of address data of customer or store locations, and then they'll enable those end users to turn that into geospatially analyzable lat longs through our API. Content location tagging, as you know, it'll label different types of media with where a photo might have been taken. And finally, another large use case for geocoding is service locators, so that users can find products and stores that are new to them. So Searchbox API is, this is kind of like our flagship search API, and it not only has all the address and place coverage from geocoding that we were just talking about, but it also includes very robust point of interest search. So basically, this means that it supports, you can look for a point of interest like the Empire State Building or the White House or whatever, but it also supports category and brand searches. So you can search for brands like Uniqlo and In-N-Out Burger or Phil's. You can search for categories like gas stations or cobblers or lighthouses. And this product gets updates weekly. And finally, it also supports searching along a route, which I'm sure you're familiar with. So it's a really great pairing with our navigation API that we'll talk about later. Go to the next slide. And just to get into some of the ways that customers do combine them with navigation APIs, you can see at the bottom of the screen there, Toyota, GM, straight away are using Searchbox today in navigation-focused experiences. Interactive search is really the biggest use case here, where you have users typing ahead, they're looking for services, places near them, searching for categories, as we previously mentioned, and finally, on the right side of the slide there, discovering places around them. You can send us a location with parameters configured to your liking, and we'll find nearby relevant results for your end user. And finally, I wanted to talk about one of our products that's currently in private preview, the Details API. The Details API is cool. It integrates with a lot of different Mapbox services, especially the Mapbox search APIs via the Mapbox ID. So basically all POIs, places, addresses, they have a unique stable Mapbox ID. They can use this ID to do a lookup against the Details API. And that lookup is going to provide you a variety of valuable data like photos, reviews, phone numbers, opening hours. There's different attribute sets that you can request. So you really only need to pay for the data that's really relevant for your use case. Our early customers are very excited about this API, and you can go sign up at mapbox.com/details. I'll pass it over to Ryan.
Thanks, Robert. So the theme over the last year for Matrix, specifically in this navigation in general, has been quality improvements. Lots of our routing quality algorithms have been improved. Lots of our backend infrastructure has been optimized, and really it comes down to trickling down to a better product across the board, not as much as here's a bunch of new features you can use, with the exception of Beyond, which we've heard about earlier. Matrix is the background for just about every operations solution. There's no such thing as a good picture for Matrix. It's one of the most boring products out there as far as something to look at. But for those of you who don't know, if you remember the old paper atlases, they had the list of all the cities across the top and the same cities and distance between it. That's all a distance matrix is. Except you get to choose the cities. You can do houses and specific addresses. And it's the background for just about every operations research problem out there that is geospatially, just when you need just distances or ETAs. As I said, we have been doing a lot of optimization. Our availability is now at 5 nines, and it has been for quite some time at this point. And our latency is pretty much, even for the biggest requests, below 1/3 of a second. We've done a lot of product discovery with our customers and have found that after 1 second, customers are inclined to move away from the app and get another. So if you're doing one ride share and you don't match within 1 second, it's over a 50% probability after 1 second that the customer is going to go to the next ride share set, which we don't want to happen. And Matrix is one of the foundationals on, hey, here's the position of the person placing the order, what's the distance to all the different providers that are in the area. So, and most of this is AWS transit time. So if you're close to one of the AWS centers, it's even less than this. We've also maximized the throughput. We have one customer, Wolt. Wolt is a on-demand food delivery company, primarily in Central and Eastern Europe, and they do 2 billion requests a day. And it's just getting bigger. This is the throughput and speed that they need to keep their operations going is supported by Mapbox and our Matrix every day of the year. We've also are making this available through different vehicle profiles, and we are improving our cycling as we speak as far as this to give much more accurate and using areas that might have bike paths or are inaccessible to cars that you can do driving traffic, cycling, or walking to make whatever your use case or your couriers need so you get the most accurate operational foundation around that. We are also, for directions on our next slide, are going to be enabling a new feature earlier next year called Route Lookup. Now, directions, as you can see, it provides a route line. It's very much exactly what you think it is. You use our geocoder to take 2 addresses, you turn those into latitudes and longitudes. Those latitudes and longitudes you put into our directions API, and our directions API will give you a set of waypoints that you follow in order to get the optimal route from point A to point B. And then you can put it on any one of our maps or our navigation SDK or our maps SDK to get it to the end user to go look at it. We're using one of the things we found with a lot of our customer discovery is they need that same route in multiple places. So we have a new beta function called Route Lookup. Gives a UUID for every single route so that once a route is calculated, you can send it to places like, hey, I need to send it to my payment center so I can calculate the pay for the courier because it's based on time and distance. Or I need to send it to a centralized maintenance facility so they know where the vehicles are. Or if you're a automobile company, if you want to have a companion app that you plan a trip on your device and send it to the vehicle so that you have the exact same route on your device. This is something that is in I'm not allowed to say beta anymore, am I? Pre-production for it, and it will be in full availability first half of next year. We have other things that I'm seeing people use. Just trip visualization displays our pricing and visualization based on your travel times and distances. We can constrain routes now around the type of vehicle using EV routing. So if you want to route based on the constraints around battery discharge based on your specific vehicle, or there's always charge anxiety. Some people don't want to go below, say, 20% charge. We can base your routing on under our known database of charging stations. So you'll never go further away than getting whatever you set, 20% charge on your vehicle before encountering a charging station. Our isochrones return a poly around a point with either equal distance or time of arrival. Our isochrones can be driving traffic profile to take advantage of Mapbox's proprietary movement and ETA data to provide a more accurate result, or it could just be distance if you wanted. Isochrones, ISO 1 chrones time, but we also offer a distance in which if you want to have it traffic enabled or not, you can choose whatever profile you do. It's extremely high resolution. Is the default is somewhere, sometimes you'll get, thousands of points in this polygon, but like most Mapbox products, it's customizable. So you can adjust the resolution if you need a less granular, lighter weight isochrone, depending on what you want to use it for. And finally, map matching. Map matching is one of those that is, if it's done right, your end user will never know it happens. I used to work on the GPS program. I know how sometimes fuzzy and convoluted the final signals are for GPS. Map matching snaps these fuzzy GNS traces that are common in like urban canyons, complex topography, and subterranean infrastructure, and snaps them to the road path network using the directions API, and produces a clean path that follows roads and can be clearly displayed on a map without looking to see the traces, bounces from a building, bounces to the sidewalk, when we know that they're actually on the roads. This API can also automatically remove duplicate redundant points because typically the device is sending a ping every 5 seconds or so. If they're stopped at a stoplight, multiple pings there, we can remove the duplicate redundant points and clean it up so that it makes the final polyline even more accurate. So I know you have a lot of questions. Bing has been following them around. So let's get started with those.
All right, I think we have question. I think the question is for you, Ryan. Is it possible to apply navigation API to private data set, such as the road and the utility network on another third-party maps, but not on Mapbox-based map?
Yes, this is a new product that is in private preview now called Bring Your Own Navigation Data Beyond. And we talked a lot about how Voy, one of our scooter customers in micromobility, is using it in our opening speeches. This is a product where you can bring your whatever navigation data you want, polygon avoidance, getting into roads, finding different whatever is important to the customer. You can add that to your navigation profile, and our directions APIs directions APIs kind of trickles down. So we use the same engine for Matrix and the same engine for isochrones and the same engine for optimization. It will take the directions engine and it will use your map data to navigate based on how you want it. The big one we see right now in our initial use case is with scooter shares. There's a lot of municipality, myself in Denver especially, that there are areas where they do not want scooters. So when you do navigation on scooters, you could say, hey, we don't want anyone driving through the Union Station area, for instance. And instead of just saying, don't go through there, it will now put the navigation polyline around the places that you have brought your own navigation data to do. So stand by for that. We're looking for a first half next year general availability, but you will hear more and more about that from us.
Thanks, Ryan. Robert, I think the next question probably is for you. Can you explain how routable points work? I've heard that you mention, you can guide the delivery drivers to the most appropriate entrance, drop-off location. How does that function on the back end?
That's a great question. So for all geocoding responses that you'll get back from our API, you'll see kind of the main lat long, which is sort of the rooftop coordinate of where this house or apartment or building is. And then you'll actually get a second coordinate in there that's labeled the routable point. And what we do on our end is we have a probability model. We'll look at all the different roads that surround the rooftop point that we have. And then we'll look at 4 different parameters to decide which one. First, we'll look at the physical distance from the nearest roads to that address point. So like how far is this road, that road, this road. Then we'll look at the similarity between the address that's the street name that's on the address, and then compare it to the street names surrounding it, like which one actually matches the street name. And then we'll also look at the angle to the matched road, like is it actually oriented towards that road or not? And then finally, we'll look at like the road type. Is this a highway or a service road? is it really appropriate for someone to stop their car there to get out and deliver food, for example? So that is all done kind of on our side. So every time you'll get back a routable, a geocoding point for us, you'll also get back that routable point.
Thank you. We do have more questions, but I think we're near the end of our time together. Sorry if we aren't able to answer your question, feel free to join our AMA. We have AMA Thursday and Friday, or post your question to our Discord community. Enjoy the rest of Build with Mapbox. Thank you.
Thanks, everyone.
Thank you.